we're talking about the 240 volt contactor. This relay right there. The relay that you will find in every condensing unit of every air conditioner that you work on. Absolutely, especially residential. You'll find this in every residential air conditioner. It goes in the condenser every time. So this is a condenser relay that goes in the condenser and activates the compressor and the compressor motor. So quick recap, we get 24 volts on the sides here, and that's what drops the plunger and completes the circuit. There's a center bar that runs down the middle of the contactor that separates 120 volts through this and 120 volts through this channel for a total of 240 volts. Today on the diagram, we're going to split it to show what's inside and what's outside. So we're gonna look at the components real quick. Our inside high voltage, line 1, line 2, our transformer, our thermostat, all components that go inside the home, inside the air handler. On the other side here, we're gonna see the compressor contactor, which we discussed is in the condenser. Then we're gonna have our compressor, our outdoor fan motor that goes on top of the compressor, and our capacitor, and how these three connect into the 240 volt contactor. So what we're gonna do today is we're gonna split our diagram. We have high voltage outside and high voltage inside, because there's a disconnect inside at the air handler and there's a disconnect outside at the condenser. So every air conditioner has two circuits, two 240 volt circuits, one for the inside and then one for the outside. So let's go ahead and split our diagram. Very little wires go back and forth, so it's perfect to have these marked in. So you're gonna get you a ruler and say about every inch or so, you're just gonna make a hash mark. 9, 8, 7, 6, 5, 3, 2. So that way, your full diagram is split with an outside portion and an inside. So let's go ahead and start with the basics. We'll go back to our transformer. See L1, L2 on the primary side. We're gonna take L2, bring it down, bring L1 down, and provide our transformer 240 volts, and then pick up 24 volts on the secondary side with our common wire. Put the common in my hand, we'll start with that notion. Okay, so looking at all these connections, you think, hey, that's a lot, where do I start? Start with our high voltage, and then we'll start with first things first, our common. This will be a quick one because we only have one relay. I'm gonna start with our common that goes, of course, to one side of our transformer. Put the common in my hand every time. We'll start with that notion. What's next? Let's get the control side. As we've agreed before, bring it directly down to red to feed the thermostat. Because as we agreed before, the thermostat is fed 12 volts from the control side, and then it manipulates the 12 volts to send it to the green for the fan motor, the yellow for the compressor contactor, the white for the heat sequencer, the orange for the reversing valve, and of course, C was our common. Red will only jump into these four to activate the relays. Red will never touch common because that will short out this transformer. So let's go ahead and let's run our yellow. We're gonna run our yellow, our control. We're leaving the yellow on the thermostat. Let's bring this down pretty tight here. And then we'll bring it over. All right, before we even get into the high voltage connections outside, we'll go over our transformer, our 24 volts, common coming to every leg of the relay, put it in the hand, and then control coming down into the thermostat, and then the thermostat sending the voltage over when the thermostat says, engage Mr. Contactor. So now let's go ahead and get some high voltage knocked out here. When we say 240 volt contactor, what we mean is that this relay is one of the only relays that's going to receive a full 240 volts. Because when we look back at our previous lesson, We had our indoor fan motor, which needed 240 volts. We had a high voltage common feeding the indoor fan motor, one leg, high voltage common in the hand at all times, just like the low side. And then the other 120 volts for the fan motor was being directed down in through the relay, the fan relay, and then turning on the fan motor by completing the 240 volts, because this fan motor will not move unless it has all 240. It can have a constant 120 on common and not turn on. But when we look at this, we see how we're splitting only 120 volts. So 120 volts leaves L2 and it stops here until 24 volt is supplied to the low voltage side of the relay, and then it's jumped through, and then 120 volts continues here. So every relay is going to split 120 volts, the heat sequencer and the fan motor relay, but the contactor is 240 volts. That's why there's two poles. This is a two-pole contactor, one pole, two pole. So we need 240 volts, 120 through each leg. So first thing we have to do is, just like we did our transformer that needs 240 volts, let's go and feed our contactor. We have an outside high voltage. This is the disconnect box that's outside. It's bringing 240 volts to the whole condenser as well. So let's take L1. Of course, we're going to jump our bridge and complete to L1 of the contactor. Same thing with L2. Bring it over. So now we have 240 volts at the base of this contactor. We have 240 volts here coming in at the bottom. Now we have to get it through the top when the thermostat closes, and then to turn on the compressor and the outdoor fan motor. Okay, so now this is where we're gonna get a little bit more into the condenser. But now that we're here with the contactor, we need to go ahead and figure out how the high voltage connects. So let's start with talking about the compressor and the outdoor fan motor. Each compressor and each outdoor fan motor that's OEM is going to have 3 wires on it. 3 wires that come out of the compressor, 3 wires that come out of the fan motor. So if we look at the wires, we're going to see a C for common, R for run, and S for start, and that's on the compressor. We'll look down at the outdoor fan motor, same notion. C for common, R for run, and S for start. Well, when we have our contactor here, we can designate one side common. So we'll make this side common. And if we make this side common, then we are going to make this side run, R. So this is run leg, common leg, common leg. Okay, so let's follow the same notion that we learned about our 12 volt common. On the side of every relay, it's to be put in the hand. So let's start with the common on both the compressor and the outdoor fan motor. So we'll start with the common on the compressor, bring it over, down, and finally all the way down here. Same thing with the common on the outdoor fan motor. We're gonna run over, up. We're gonna be crossing some lines there, so we'll go up a little bit higher. Cross over, start our bridge. And it comes down to the common side of the contactor. If you look at the contactor, that's why I said you'll notice that there's multiple connections. There's 4 spade clips here. There's 2 wires that are feeding into this common side of this contactor, the common from the compressor, common from the outdoor fan motor. They're both feeding into the common side, and what makes that possible is we have 4 legs. So I could hook up more than just one compressor and one outdoor fan motor. This machine could have 2 outdoor fan motors, where it may need a 3rd common going out to a 2nd fan motor, or another common because it has 2 compressors and 2 fan motors. This relay is very universal. You'll find this contactor relay in almost every condenser you're going to come across. Little crazier when you get into commercial, industrial, but with residential, you can expect to always see a contactor in the condenser. So we've discussed and agreed that this is our common leg, We've brought common to the compressor, common to the outdoor fan motor. Now let's go ahead and look at our run leg. Okay, now we have a run leg on the compressor, run leg on the outdoor fan motor. So we're going to run the run down pretty close to the other one, the common that's coming down. We're going to jump a bridge and bring it all the way down. So now we have connected the run leg from the compressor to the run side of the contactor. There's two sides, your run side and your common side. Okay, so now we're working on the run side. We've brought the run down from the compressor. We have a run on the outdoor fan motor. We're gonna bring it over also. Bring it over, travel up, make a bridge, and come on back down to the run side of this 240 volt contactor. So right now we've gotten all of it. We've gotten the outdoor fan motor run and the compressor run. So what's left is our capacitor. We keep seeing these capacitors. And we need to understand how they wire in to every compressor and every, every outdoor fan motor. Like I said in the very beginning, all this wiring is down to the basic level of every air conditioner. So regardless of the brand, if you're working in a residential system, you are going to experience exactly this. And you have to be, if you want to do a service tech, you want to be able to fix an older machine, you're not always going to have a wire diagram. You know, so you have to be able to identify what's common run and start on the compressor, the outdoor fan motor, and be able to, you know, replace a capacitor and not even have the wiring diagram, but you know how everything connects into one common side of the contactor and one common side of the run side of the contactor. So let's go ahead and get our capacitor connected. So what is a capacitor? What a capacitor is you can consider a capacitor as an artificial third leg of energy. So an artificial third leg, might as well say it's a fake leg of energy. Why do we need that? When we look at the compressor, this compressor has 3 lines coming out. You can almost think of them 3 windings. Common, run, and start. That's 3 lines. Outdoor fan motor, common, run, and start. 3 lines. Okay, when we say something like 3-phase, we mean that we want 120 volts, but we want it 3 times. We want it L1, L2, L3. And when you get on top of big rooftops and big commercial units, the majority of those have an L3 on the outside. And the reason we do that is because if you have 3 120 volt lines coming in, then you'll never need a capacitor, because your start on both of these would go directly to L3. So why do we have 300, you know, big high voltage that has 3 legs of power? Is because it eliminates the needs for start capacitors and run capacitors. So let's see how we turn this capacitor into an artificial leg of energy to almost simulate an L3. We don't have L3. We only have 2 legs of power coming in because it's only 240 volts. But we need to simulate a third leg of energy for the start leg. One on the outdoor fan motor, one on the compressor. Capacitor is how we do it. So we'll start backwards. We'll go from hermetic and fan. Remember that hermetic on the capacitor always feeds the compressor. So we're going to go to the start leg. We're going to come on down and hook up to the hermetic. And that leaves us very comfortable here. Here's our outdoor fan motor, our start leg. I'm going to bring that back, connect right here with the F, the fan portion of the capacitor. So what does that leave? That leaves common. That leaves common on the capacitor. This is where this common, you naturally want to put it with the other commons. Absolutely, that's what we've learned the whole time. Only in this case, the capacitor, every capacitor is fed on the run side. And that's why we have 4 legs, because one of these third legs will come off here. It'll come off the back. and it's gonna head up, jump over, head over, another bridge, and the run side is what feeds the common on the capacitor. You think it'd be the common side, it's not. The common is, on the common side of the contactor, is strictly reserved for the common leg of the compressor and the common leg of the outdoor fan motor. Those are the only things that are gonna be over here on this common. Traditionally, in almost every system that you're gonna get to, this common here is almost always gonna be black. Sometimes your run colors will change from red to yellow, but in that case, if that was the case, then the red on the compressor would be run, and down here this run would be red as well. So they try to make this color coded. So when you pull a condenser off, you'll see a bundle of black wires here, and then a bundle of yellows or reds. And then one of these yellows, one of these yellows or reds will leave the run side of the contactor, and it will head over and connect to the common side of the capacitor. So we have another leg of energy hitting the common side of this capacitor, and then we have one leg leaving hermetic, going to the start winding on the compressor, and one leg leaving fan, heading to the start winding on the outdoor fan motor. So what this capacitor is doing is it's maintaining a charge rated in microfarads. It's MFD, it's microfarad rated. We're gonna get more into capacitors. We're just sticking into the diagram right now, so we'll touch harder on that. But this is what a capacitor does. Holds a charge because it's being fed from the run side, not the common side. It's being fed from the run side, creating a charge, and then we're feeding a leg into the start leg of the compressor and the start leg of the outdoor fan motor. And this is what a capacitor does. It eliminates a need for us to have L3 down here. Because if we didn't have this capacitor, this start leg would have to go to L3, and this start leg would have to come down to L3. When we're doing residential, you're only gonna experience 240 volts. When you get up on rooftops, now you're doing 3 legs of energy, 3-phase power. This is 3-phase power, this is 2-phase power. When you work on L3, when you work on a machine that has 3 phases of power, every time you take off the panels, you have to say a prayer, because this can literally kill you. 240 will hurt you. 330, 360, this will really do some damage. So that's, again, another benefit of staying in the residential side of the business, because in the commercial, you're gonna be dealing with L3. But again, you have L3, and then you won't have capacitors. But in our residential systems, we use L1, we use L2, we keep it 2-phase. We run the L2 up into the run, split a wire off to the common of the capacitor, feed the hermetic, feed the fan, and that completes our high voltage for the outside condenser. We will go deeper into this. The whole point of this is to tie in, again, let's keep it back to the contactor and the low voltage relay. This transformer is consistently sending its 12-volt common, keeping this side charged. This relay won't engage unless it gets its 24. Thermostat says, Mr. Homeowner's hot, turn on the cooling. 12 volts is jumped through the red into the yellow. It travels, closes this contactor down. It closes these poles down, completes the circuit, and now the compressor and the outdoor fan motor turn on. Before we go, of course, now we're going to go ahead and do our wiring size. I like to take a thinner marker because, like as we discussed, your wiring diagrams that you investigate that are going to help you in the field are going to do this with their wires. It's very important you do the same thing when you make your diagrams, because you want to show that you can distinguish between high voltage and low voltage. It's going to get a little tight here, but we can do it. We're going back to the common side of the compressor, bringing that on down, underneath. Very good. We'll do it back the same way, common side of the outdoor fan motor. Bring it underneath. And we close and we show the high voltage. Bring our red for our run. Bring it down. Go over your same wires, your nice bridge. And we're there. Just a few more. We got our red from our outdoor fan motor. It also needs to go to the run side of the contactor. Bring it over. Our bridge connected. Leaves us 3 more. We're feeding the common to the capacitor off the run side, never the common side. We're gonna run out here the back, make our bridge over, bridge again, feeding the capacitor, and then we're gonna bring over our hermetic leg to our start and our fan to our start. Every compressor you come across in residential will have common run and start. Every fan motor, OEM, which means that a brand new one or one that was original to the machine, will have a common run and start. We're gonna get more and deeper into the fan motors and how deeper they go. We have our key here, right? Our key. We had a few abbreviations here, COMP. Look into our key, COMP is compressor. We had OFM, outdoor fan motor, and then capacitor would be, if you just had a right cap, you could put capacitor down here. We'll do our line markings. Thick line equals high voltage, and of course our thin line is going to equal low voltage. We're slowly putting it together, but just realize again, the very grasp of all of this is low voltage and relays are made possible by the transformer. If there was no transformer stepping voltage from 240 down to 24, we wouldn't be able to control all of this high voltage with nothing but one little yellow wire saying engage and control high voltage with low voltage, because that's the relay game. Hang in there. We're gonna go and get into the reversing valve next. After the reversing valve, we put the chart all together and then we move on, and then we come back and keep practicing. We're doing excellent. Let's hang in there.